Yeah, we're waiting for the drink and nice waffle here. This store is called Neo in Vancouver, one of my best or favorite waffle and hot chocolate shop. Leo, right? And you mentioned this about your very first time in Vancouver, but what brings you here this week?
I'm here for LDB. It's a conference on very large databases. My colleague and I have a paper at LDB. In fact, my colleague has two papers. I only have one with him. That paper, sorry to brag, it won the best paper award, or one of two best paper awards. And the nice thing is that this paper, it's pure theory, just mathematics, but this is the theory that our company is based on.
Okay.
So our product is basically an implementation of this new algebra called DBSP.
And that's also open source, right?
The implementation is open source too, under the MIT license.
Yeah, nice. Yeah, congratulations, you guys won the best paper. Is that a surprise or you know already before the trip?
Oh, it's always a surprise. I mean, we thought it was a good paper, but it was a pleasant surprise.
And you work with Frank, right, from Materials?
Yes. We've been collaborating with him for many years, in fact.
Okay, cool. Wow. So, we're waiting for the food. Maybe you can share a little more about what's the kind of breakthrough of this paper or the project you're working on right now?
Yeah, so if you look at the theory of at the history of databases, there was this pivotal moment when they started building relational databases based on relational algebra. And if you look at a modern database, there are millions of lines of code, there are all kinds of crazy optimizations and lots and lots of complexity. But at the core, the reason it all works is because it has this clean mathematical formalism underneath. You and I are building streaming databases or streaming analytics engines, things that run similar kind of queries over moving data. And at Founder, we believe that you need a similar kind of foundation to build these systems. They're also going to become extremely complex over time. We're going to build all kinds of clever optimizations, but all of that needs a very clean foundation. Otherwise, it will just fall apart. And we're not the first to try and build it. In fact, Frank's differential data flow work is similar in spirit. It has similar goal, and that led to this amazing system, differential data flow, which is also the core of Materialize. So our formalism is inspired by that. In fact, we started working on it as we try to kind of explain to ourselves better what differential data flow is doing in our previous project. And so we started with, okay, let's just formalize differential in a way we can understand, but this kind of grew into an independent theory that is not exactly comparable to differential data flow. You could say it's similar in spirit, it's similar in capabilities, but it's not a subset or a superset. And it has this nice property that it takes the problem of incremental computations. Incremental computation means computing on changes. It also takes this related problem of streaming computation, which is obviously computing on streams of data. And it says that those two things are really the same, because streams are really just streams of changes to some kind of relational table. And it builds essentially an algorithm. At the end of the day, that's what it is. An algorithm that can take any relational query. In fact, much more than that. It can also take recursive queries. So if you're familiar with data log, it's basically a relational algebra plus recursion. So it can take any such query and syntactically, without doing some complex heuristics or complex search, convert it into an incremental implementation. Incremental implementation means... Thank you.
Thank you. Yeah. Now is the coffee part. Yes.
So incremental implementation means that when we get a new update or a new batch of data from the stream, the amount of work that the algorithm will do to update the results of the queries is proportional to the size of the change. So you can have a database with millions or billions of records, and then you have 1,000 new records, or 1,000 of updates to records in the database, and you will do only the amount of work proportional to the new data. So that's one nice property, and the other one is that the theory is very modular. It basically tells you that if you have an incremental implementation of an operator, or of multiple operators, you can simply put them together. So when you have a new operator, you just build an incremental implementation, you plug it into your system, it just works.
Yeah, and there's a lot of stuff to digest as early morning also. But
well, that's where your brain works the best.
okay. And I know that is, for example, in Template we're also building some like append only, and also later on there's a change log or version in the stream. We even have to implement different version of aggregation functions to aware of like you add the new data or you deduct the data, right?
Right.
So for example, like as simple as count can be very tricky because it's not always add. You can actually degree.
Oh yeah.
Yeah.
Oh yeah. So the definition of incremental computation means that you have to deal with insertions and deletions. So you can incrementally update results even when you have destructions with the same complexity. But I think you're also making a good point that there is this whole, especially for things like aggregates, there is this whole design space depending on the aggregation function. Right. So for example, things like count and sums and averages are linear, which means you can compute them without storing the state. And then others are not linear, so you have to store, you have to index your relation. And then the other dimension is, if it's an append-only stream, you can have a more efficient implementation. For example, append-only computation of a max function is very efficient because you only need to store the last maximum, and as you have more data, it can only increase. But if you have retractions, you have to store the entire data set because any old value can suddenly become the biggest value after retractions. So yeah, definitely, and that's basically our view of this is if you have a principle framework for dealing with changes, then all of those things just fall into place. You can have a default implementation of this thing that may not be the most efficient, but it will work, and then you keep adding optimized versions. But the math gives you the exact reason why it's correct. You will know exactly why it works and what you need to do to make it work.
Do you have a goal to like just take the existing, say, MySQL or Postgres SQL and run this in your system and just works?
You mean, would you like to use it as incremental maintenance for something like Postgres or MySQL?
Yeah, because I checked the website, one of the really interesting part that you saying that almost any SQL can be streaming SQL without changing anything, right? Using new syntax.
You're talking about the queries, the queries we can write. Yes, that's the goal. It's not so much about like supporting the exact dialect, although we're working very hard to be as compatible with as much existing SQL as we can. It's more the fact that we'd like to be able to take the standard SQL semantics. So everybody knows what a SQL query means. And we want it to mean the exact same thing in the streaming context. So if you stop Foldera is the name of the system you built. If you stop Foldera at any point in time, then the accumulated output of Foldera is the exact output that a normal SQL database would give you, given the accumulated snapshot of the input stream. So the input-output relation is the same. So you don't necessarily have to invent new things, you just have to interpret SQL in the streaming context.
Do you consider what we call Fedora, right? We can talk about the name later. So using Fedora is more like a stream processor or more like database with storage?
Yeah, that's a good question. And the thing, by the way, I think it's one question that all the companies in this space have to find an answer to. It has a lot to do with how you explain to customers what you're offering. I would not call it a database. To me, a database is something that lets you answer ad hoc queries or historical data.
Yeah, it's for him. Yeah.
And then many more.
Yeah, for me and all of us here. Thanks so much.
No worries.
Perfect, thank you. This is our breakfast. I don't have such a kind of heavy or kind of amazing fancy breakfast as usual, but never mind, try this.
Yeah, you'll get to be hungry.
Okay, cool. Yeah. Help yourself. Yes.
So I wouldn't call it a database, because although it obviously has to maintain a lot of state internally, it is not designed at the moment to answer ad hoc queries. It might come in the future. I don't think it will ever be the forte of this kind of systems.
Do you have storage?
You have to have storage. To do incremental computation, you have to maintain all kinds of indexes of the input data and the intermediate results.
It's more like similar to Flame, right? It's more like a state, like something similar like LogDB, but it's not the storage for the raw data or like historical data for the past, say, 3 months or 3 years.
We're not trying to be a data warehouse. So what will happen is for whenever you look at your queries, it will figure out exactly what it needs to store. So if you happen to have, for example, a query in your system that joins an entire table with an entire other table, you will have to store the full history of the table, or rather a full snapshot of the table from the beginning of times. Or if it has a really large time window, like a 3-year time window, it will end up maintaining 3 years worth of data.
In memory or it's mixed?
So at the moment, the engine is in memory. You're building a persistence layer because obviously, you don't want to be limited by the memory size. So we'll probably build on RoseDB or something similar. Our proof of concept works in RoseDB for storage.
Nice.
But anyways, it doesn't make it a database. Just because you have the state, unless you can also answer ad hoc queries, I wouldn't call it a database. And streaming analytics, it's kind of just unfortunately extremely overloaded term. I no longer know what various people understand when they say streaming analytics, what they mean by it. I feel like the kind of really powerful general purpose SQL processing that we try to build probably exceeds what most people think about when they say streaming analytics. I guess technically it is. We compute on streams of data. We prefer the terms like continuous analytics, which emphasizes the fact that you write some queries ahead of time, and the system makes the latest, most up-to-date results of the queries available in real time. So it's continuous, as in you always know the answer to all the queries, even if it would otherwise take hours to run them as batch jobs. We also talk about data in motion, computing on data in motion, because most use cases we see have to do with data moving from source to destination, and where normally you would run some kind of DBT job, some kind of batch job on the destination database. We can do it on the fly, on the data en route.
Okay, nice. And I guess we roughly met online, right? I don't know, maybe half a year ago or 1 year ago, in Tempest Slack.
Oh yeah.
At that time you were in VMware.
Okay. So how about you guys? When did you get started?
Less than 2 years, almost 2 years, I would say. Yeah.
And were you working like in this domain before you started the company, or did you have some code before? Did you have some previous product?
So I spent for a while I was even in EMC, right? EMC and you know this interesting relationship between EMC and VMware. Yes. For some time EMC is the mother company for VMware. I guess now it's the opposite. Kind of interesting story. Anyway, I spent 4 years half in EMC on the documentation product line, which is more like enterprise search for the content. So many of us actually, for example, our Template CEO team was the hiring manager at that time. He bring me to VMware, and I got to know him starting from 2008. And after that, 4 years half in EMC, I moved to Splunk, like the log analysis security company, for almost 7 years half. So including 3 years here in Vancouver. So I think I share with some of the folks that is my last 2 years in Splunk actually is building this called data streaming processor, DSP, and we leverage like Flink, Kafka, Istio, Polsa, all those stuff to build a solution so that traditionally data have to be indexed by Splunk, and you run a query every X minutes to get the result. Hey, how's the average CPU looks like? Am I being attacked? Or other kind of security issues, but it's very natural. People, hey, I don't want to run this every 3 minutes. I want every 3 seconds can do it. That would be very, very expensive because everything will be go over that tokenization index, then query again. You end up with, you know this very well, like this waste of extending data over and over again.
You're doing those all from scratch.
Yeah, so they do need something like continuous monitoring or like streaming or NSS in motion, stuff like that. So it's very natural to use stuff like Flink, Kubernetes, Kafka, Polsa, all those stuff. But I guess the overall experience is kind of too many moving parts. We have over 100 engineers on that project. We deliver this to some customers, but we think that can be different ways of doing so. So after that, I left this firm. Some other folks also left this firm. We try to solve this problem in a different way. For example, you know the company called Decodable.
Yeah.
So Eric Summer was our lead architect for that DSP project. I managed maybe about 30% of the engineers as an engineering director. But Eric Summer is the lead architect. He's still very passionate for the Flink, but also try to build fully managed Flink in the cloud. So that's essentially how Decodable it is, right? Starting from fixed CPU, but now they also accept arbitrary Java as a runtime in the cloud.
And how come you guys decided not to go with Flink?
Yes, that's an interesting question. So, for example, next time I go to Decodable, the Polsa folks go to Databricks. For example, Classic now is the head of streaming at Databricks. They are working on this Spark or structured streaming, or project lightning or data live table, something like that. We use our team also kind of familiar with Flink, but we're not really so influential, right? So for example, we don't really have the PMC in our team or in our network, and we feel like this is a little bit too heavy. So our approach is can we build somehow a database but with time as the first decision? This is very similar to the idea of Splunk. But Splunk is not really relational database. It's not a stream database. So we try to do that, and we also don't really want to build everything from scratch, right? It will take multiple years. So our approach is we're focusing on the streaming part, and we also choose kind of existing OLAP system as our base. So we end up with choosing ClearHouse. That's something we're going to announce. Yeah, this month. So we are going to announce this so that we have a partnership with ClearHouse.
Yeah.
So we are trying to build a true streaming database because it's a database. You can save any data there, if you want to query in old fashion, just using us, but we will somehow leveraging actually the ClearHouse code to do that. But if you want to do something incremental, or you want to do some like change log, or even do some join, actually it will be part of our code. And we also build a very special module similar to Kafka, but it's not general purpose. So because it's very common for a team to use, hey, I set up a Flink, I set up a Kafka, I set up a ClearHouse, and then do everything together as a solution. In our case, we have everything in a single binary in C++. So it can give us a better way to more efficient and also do some tuning.
So how does state management for the incremental computation work? So if you mentioned that you can do, for example, incremental join. So would the data still live in ClearHouse, or do you have like separate storage for this kind of computation?
Now we are in an active discussion with ClearHouse, so we are planning to merge something back. But how we use ClearHouse today is we take the code and modify in the liquid deal. So there's no really a separate ClearHouse process. It's part of our single binary or engine. And we even change the data format. So for example, we know certain data need to be queried in a batch way, and also the same data can be queried in a streaming way or do some kind of join. So we have our own data format. We call it 10 plus data format, TDF. So it is consistent representation as OLAP storage, as streaming storage, as memory storage. So we try to avoid those marshal stuff. So we don't copy one data in one representation and convert it to the other representation. It's essentially a single file or single piece of data can support the stream and the batch.
Right. So basically your ClearHouse engine works with the same data that you're streaming.
Yes.
Nice.
Yeah, and then we have our component we call native log, which should be nothing compatible with Kafka. We can use Kafka as our streaming storage, but we don't want to manage too many moving parts, so we have our own version of this streaming storage. Essentially, it's saving the LSM and the red hat log in this stuff. It's not kind of arbitrary all these things, so it will be more efficient for you to like fast forward or backfill.
Interesting.
But those stuff will be open source. Like this
Oh, that's very cool. I was wondering about your open source strategy. I noticed that right now not a lot is open source in the 10 plus.
Yeah, we just open source some kind of client or SDK. Yeah, I guess this we'll be discussing this like 2 years, almost the same time as the entire journey. We always discuss what's the right time to open source. Should we open source? I guess to some degree that is we did want to move very fast, and we are really a small team. I'm not quite sure what's the capacity for us to like maintain a very active community and getting a lot of contribution from the community. But on the other hand, we do kind of leverage ClearHouse, we leverage other stuff such as Benzos, or say our JavaScript EDF is based on Google V8. But we already leveraging some of the open source stuff, and we do want to contribute back. And also, more importantly, I think developers naturally want to try everything on the laptop or set up a local cluster without talking to the salesperson or using the cloud version.
Right. And for that, you technically don't need open source, right? You can still distribute binaries.
Yeah, the open source can build a better trust. Right? Hey, this is the code.
Oh, I think so. Like we definitely choose the open source approach for all the core components.
Right? We don't really have to like open source everything. Like our UI will have open source, our co-ops, some other advanced feature enterprise. We don't have to put in the initial patch of open source.
So how do you guys go about scale out?
Yeah, scale out. That's also very tricky. That is, we design our own protocol so that we have multiple nodes. How they sync those metadata how they select all those fun stuff. So it's not easy for sure. That's also one of our biggest investments, and that's also a high requirement for many of our customers.
Oh yeah, definitely.
Yeah, they don't need the feature is so like 100% perfect that there's a cluster that can restore security is must have.
Yeah, and especially like one thing we noticed is once you offer this real-time analytics, once you say you can do things in real time with low latency, well then people want to be sure that even when it crashes it comes up quickly, because otherwise the real-time guarantees go down the drain.
Yeah, and to keep the state, we recover from that same no duplication of the
If you have to start from scratch after a crash, then it's not real time.
Yeah, that's right. And this is really a lot of challenges. For example, you also work on this continuous monitoring. So for example, like if you have a query, if the query fail in the middle with some unexpected data, right? So do you need to like stop immediately? Do you want to keep working on but having that data in some data queues? There are a lot of design choices.
It's a big problem with streaming systems. You cannot just stop. You cannot just roll back the transaction. You just have to keep going.
And also, what if you have a new version, right? So
That's
can you secure all those upgrades, quality issues?
Yeah, so right now the part that seems to make the most sense for us in terms of error handling is you cannot throw errors back. Like there's no back. You cannot send them back to the sender, so you can only throw them forward. Yeah. So you just output by building separate output tables. You just report anything that went wrong.
Yeah, and
It's up to the user to handle it.
yeah, even in the batch world, some stuff already like challenging enough, such as like schema drift. Like you have a new column, you have a column type change. But in the case of streaming, it's even worse. For example, you already know a query with like 3 columns, but suddenly there might be 4 columns, but you don't really have a chance to say, sorry, I'd rather change from 3 columns to 4 columns, same results there.
Yeah. A lot of the things you fundamentally cannot do in real time. You have to rebuild so much state that this cannot be real time anymore. So there are just fundamental limits to what you can do in terms of schema data. Some things are doable, like adding a column is in principle doable because you don't need to change any of the state you already called. But adding a new query, for example, requires building indexes you just don't have.
Okay, yeah. Very high starting point, right? Like your first attending of is winning the paper of that paper.
Yeah, that was nice. I have a question about time plus.
Yeah.
The way you explained it sounded like you're first and foremost a real-time analytics database with ClickHouse at the backend, and with streaming incremental analytics as kind of an added capability almost.
Yeah.
Can you talk about how expressive your streaming part is? What kind of queries can you handle in the incremental mode?
Yeah, that's almost our solo focus, right? We do have some other UI or some solutions, but we spend a lot of time to have that engine. I would say have a similar capability as Flink, right? So we do have those stuff like watermark, you have this tumble window, hop window, and all those even changelog, materials view, or materials view on materials view. And especially for the joining part, I guess to some degree we are even more flexible than Flink and ClickHouse, because if you do the join for the streaming part, again, it will be quite different compared to the OLAP-based join, right? Because you are not really talking about scanning a lot of data. You are talking about what the data from different streams, how you maintain in memory, and a hash map, and how to dispatch the different workers. But in general, we are very confident our kind of joining streaming SQL syntax is quite powerful. Yeah, and for example, like some of our use case or clients, they are not just using apparently, right? We start from apparently for sure. Everyone starts from apparently. But later on, people naturally ask, hey, for example, in the case of Web 3, you might have using some blockchain, and the chain can be in different states, and you don't really care too much about this state in the middle. You want the end state, right? Then you really want, hey, with the same ID, can I use the latest version and override the previous version, and we should apply it to all my count, sum, min, max. So we spend a lot of time to work on those. We call it change log or version stream. Essentially, it's a mutable streaming with certain behavior as both OLAP and OLTP. People want something simple, but the underlying knowledge is quite complex.
Is any query that can run in ad hoc mode? Is it also going to work in the streaming mode? Is it the goal to support the same set of queries?
Not exactly. So our choice right now is that is in your query, we know exactly this will be a batch query or it's a streaming query. It depends on this select whatever from that path. And if you just put a stream name, for example, my stream, then in our case, we always query the data from now to the future. Only the new events will be put into this stream processing pipeline or query pipeline, but we don't care about the past. But if you really care about the past, you have this special we call table function. You just wrap your name as a table. Then in that case, we don't care about anything for the future. We only query our historical storage, which is held by the house. And then you can do something in the between. That is, I can have a query, have a data from the future, have a data from the past, or you can do some drawing. For example, if your dimension is fixed, you can wrap this as a table. You can put it apparently on the left. So it will be apparently drawing a table to some static map. But you can also using a dynamic 3C-based string on your right side. So it will be a dynamic drawing. For example, you have your transaction, and on your right table, on the right side of the drawing, it is more like a currency. What's the latest currency for USD, for Europe? And any side of change will trigger new result. And we also do some interesting in the middle is we call time travel. That is, you run a streaming query, by default it will look for now to the future. But if you also want to include in part of the history data, you can have a special kind of a way to express. I want to travel back to 2 weeks ago, and from now get that 3 weeks, and also including the future ones.
Okay, so it's not just point in time query, it's from 2 weeks ago to all the way to the future.
Yeah. Like from the past to forever.
Got it.
But again, there's a lot of choices, right? So in many cases, when we try to integrate with a BI system, like for example, like Metabase or other, they don't really have this idea of continuous query. I guess you might face a similar challenge. They just want to run the query, get the result. In that case, we have to change our parameters so it's become a bounded query.
Okay, it's interesting. I obviously was following your website and your Slack, but I think I'm understanding much better now what you guys are doing.
No, that means that we didn't do good enough job to explain the behavior.
That's not how much. It is a very complex space. And it's possibly try to balance ad hoc with streaming queries. I didn't fully realize that this was the approach. I think that's quite different from the approach we're taking. So for us, if you want ad hoc queries, you will run them on either source or destination database.
Okay.
Right, so for example, you use Founder to compute your queries and write results into Snowflake, and maybe write the raw data to Snowflake as well, or ClickHouse or any other transactional or analytical data warehouse or data lake. And then any kind of ad hoc processing you will do it there. But our job is to run your SQL queries in streaming mode continuously. So it's kind of the extreme point of our design space, all the way to just purely continuous analytics and streaming data. Now, we will still need to solve the problems like, how do you add new queries on the fly, or how do you modify your queries? So at that point, it will become some kind of hybrid system, which also needs to manage state and support a form of ad hoc queries. But we don't take this view that we try to do both. I think it's an interesting trade-off.
Yeah,
It's not obvious that one product is better than the other at all.
it's a choice, right? So I know, for example, like Materialize, their latest cloud version is more like database, right? So you can have the long-term storage in Materialize. You don't have to send back to other database. Similarly for like Rising Wave, they're using S3 as the storage.
So it's essentially this is another aspect where there is some confusion. Any such system has to have storage in order to do what it's doing. Like Materialize, in order to evaluate queries on the fly, it needs to store data. And I believe that Materialize now also has support for ad hoc queries. I might be wrong, but I think it does. So it also needs storage for that. But there's a difference between just having storage and being an analytical database. So Founder storage is currently just used to maintain your standing query.
Yeah, or even that term called, for example, this Pymon, right? Apache Pymon, this is called flipped table store. Whether it's a table store or it's like state store. I mean, every system has a certain kind of a state store for sure. Whether you really want to build a table store by yourself, it's a choice. And it's a hard choice, actually. There's a lot of consequences.
What types of customers do you guys take into? Where do you see the most interest for this sort of technology?
We actually try different we call sectors or industries. For example, I even come up with a documentation with the showcase. If you check our link, that is, we already tried maybe almost 20 different solutions. Like real-time marketing, social listening, all those product tracking, whatever it is. But what is very promising right now for us is maybe three pillars. One is fintech, IoT, and the general data platform. So especially for the fintech side, it's people really have a high expectation for the low latency part and as low as possible. For example, some of our customers make it very clear, hey, $10, I already have the system running with like 1 or 2 seconds end-to-end latency. Can you do this like 10x faster? If so, we can have a discussion. So we always give them something like 10 milliseconds end-to-end, which is very nice. Also, they do have the budget. Right? For example, they use the system to measure how efficient those algorithm-based training is. So we can help them to run some training algorithms, but maybe as a first step, it's not really on that critical path. It's more about as a validation. So, for example, they have a program to automate the training, but they need the other program to measure how that works. And this also need to be in a similar kind of 1 or 2 second delay. So that's something we're working on. Also, we have a lot of stuff like CDC or those kind of state management and also media, because that's interesting stuff. And IoT also, like people having all those cars on the road, they have a lot of sensors in their factories. and also some general data platforms such as move data from A to B in different groups, filtering, try, and stuff.
It's incredible that our findings are so consistent with what you're describing. To the extent that we also found that fintech companies are the most open to this kind of innovation. Like in theory, there are so many different domains where this could be useful. But somehow fintech have the mindset and the budget. But we also found that usually the first use cases are very much kind of support system side. Like monitoring for the main pipeline. So that's a very interesting.
But the cycle is also quite long because they are being very serious. I mean, folks in the fintech company. I mean, it's hard to get the trust with the POC, close the sales cycle. It takes quite a long time.
I suspect that in this domain the sales cycle is pretty long in general.
And they are not really cloud users. But I'm not about you, but we try to encourage our users to try the cloud. But especially in the fintech, if I would try Tampa's cloud, the cloud offering.
They definitely they are not keen to send data to anybody's public cloud, especially a new startup. Which is why I think our cloud infrastructure initially will be virtual private cloud. So which means that they never send any data to us, we never see any data. So they control, and yet it comes in some kind of standard form factor that we know how to manage. Well. I mean, you still want public cloud, and you still want cloud sandbox and that kind of offering. But I agree with you that it's a very tough sell to tell people, just here's our cloud, manage it, and send us your data.
So we work on something like SOC 2 for the cloud, but at least for now, the medium or large client or prospect, they are more leaning towards the on-prem. That's also somehow we think kind of a differentiator for Tampa's with other vendors. Sorry, Alexander, if you're looking at that, but Decodable, it's more like cloud-only solution. I mean, this only works in AWS, maybe also GCP, but we don't want to on-prem version of it.
That's because it's so dumb how to manage things.
And also you have to handle a lot of detail by yourself, right? So if you're using AWS, then you can potentially upload some of the components to the app service that you have a certain lockdown. It may make your life a little bit easier, but also have other consequences. It's a tough call. So we essentially it's a C++ shop, so you can easily deploy on-prem or even on edge, right? So this is not something we do right now, but there should be no problem for us to support like ARM-based smaller device.
It helps not to have JVM.
For example, our friend the Panda, it's more like replacement of Kafka, right? So there are some cases where Panda is deployed in smaller devices, and it just works. And also, I think they even send some device to the space. Kafka is in the space using a Panda.
Interesting. And what's your take on? You build this nice engine, but then you need to get data in and out, and so you need connectors for like everything under the sun. Are you guys writing them Division or some other platform for that? Are you building your own thing?
We primarily support stuff like Kafka and Pulsar.
That's just the message queue.
So that's our kind of built-in features, right? At the database level. So in our Tampa database, which will be open source this month, that can natively support Kafka for sure. That's easy. That's must have. But as we mentioned earlier, there are so many different resources. So we have so database layer is tier 1. The tier 2 is in our cloud offering. We have extra components as our connector service to talk to different systems, either as a source machine, for example, how to support like email service, Slack, like PDT, all those stuff. We have a component there.
Is it, so can I ask, is it also built in cloud or are you building it something?
This is not cloud only, but we offer that for our Kafka's cloud and our on-prem kind of enterprise customers. So we leverage a component called Benzos. Benzos, I guess, is written in Go. I guess also the guy from UK, I guess. So we choose that as our basic framework for the connector. So it can support stuff like MQTT, or the Webhook, or the Alpha, Kafka, stuff like that.
How about connecting to things like Postgres and MySQL and other databases?
Yeah, so our end, Benzos supports Postgres, but it's more like, hey, run this CQ, get the result. But if you want something kind of more moving change log, then leveraging the Debian with the Kafka Connect.
Yeah.
Right, but we don't manage Debian for customers. So
they manage their own division, but you guys will support the CDC format.
That's right. We have a special handling for the Debian CDC format, like this before, after, and converting to other column key stuff.
And do you find that it's a significant barrier for people to have to build and manage the business?
For example, right now, some of our on-prem clients, they need to use the Debian, right? So it's okay for them to, we set up a Debian for them as a kind of like project, not as a product, right? So hey, this is 10 plus, and we already have a database, so MySQL or Postgres, you want to send live data, then you haven't using Debian yet, I can set up a Debian with stuff like the Panda for you. But that's not our product, it's just part of the solution. But for the cloud, we don't manage Debian.
So it's interesting. So what we find is that, as you mentioned, a lot of the customers are fintech companies, and I guess that huge ones that have big enough IT department to do all that, but many of them are kind of mid-sized startups.
Yeah, sure.
They do have, the data engineers, and funds building all of that. But additionally, managing something division is significant overhead.
Yeah, that's the reason why I think someone made a smart choice to hire. His name is Roman, right? So he's one of the key contributors of Debian into Decodable. So I guess somehow, I'm not sure Debian is kind of manager service in Decodable. And similarly, company like StreamCat, right? So they also offer CDC and Debian in their cloud services. But again, actually, when we talk to some of the fintech companies, they start from Kafka or Debian, but to move the next level low latency, they even expecting having even lightweight protocol. They even have their own protocol, TCP based.
Yeah.
So that will reduce from say 20 milliseconds to 2 milliseconds.
Oh, so that's like some kind of high frequency trading.
Yeah, even that is not really that high frequency, but they do have this requirement to push the boundary to minimize those kind of, especially everything deployed on-prem. You don't have those stuff like those MTLS or those authentication. We can minimize that kind of requirement on security because everything deployed very securely. And we just try to find the best, most efficient lightweight protocol to talk to each other.
Okay, makes sense. It's amazing how much of the job is about just making different things work together. And I think part of the problem is that databases weren't really designed for this. Any database works with input streams of changes, like transactions are basically changes, but they're not good at producing output changes. So it's, which is where this whole CDC ecosystem came from.
Yeah, I guess to some degree this is, I agree this is not really like a database as a traditional language. It's more, traditional concept is more like kind of a streaming application server. Yes, it is a logic. This is more essentially application server for you to run logic.
Oh yeah, but what I was talking about is more that this thing that we are building, it has to work with databases, with upstream and downstream databases. You know, we get inputs from databases and we write outputs oftentimes to another database. And there is no, databases weren't designed to send stream of changes to a consumer.
No, you're right. Yeah.
They have a different API. All the CDC products are, in a way, it's kind of a hack on top of something that wasn't designed to do this. And I think it's a source of a lot of complications for us.
Yeah, so that's why even this idea about like no matter stream database, even questioning what's the exact definition of stream processor, streaming warehouse. I even saw a blog from Yazoo today this morning about streaming data lake based on Kafka. I'm not quite sure about that because anyways, Kafka can be expensive.
But usually what people mean is you stream, you ingest streaming data, which is different from analyzing data in real time as well.
And then there's also other problem in the batch side. GPT is still a big thing. And then all those data lineage, data quality, data governance, there's a lot of problem. And the streaming is not going to solve all of them, even make these things even more complex.
Oh, definitely. And I think that's another reason why I'm not particularly interested in replacing data warehouses or even data. They do a lot of things really well, but I don't think we will ever have the manpower to do well. But we can do real-time analytics on the fly. We can do continuous analytics really well.
It's a very dangerous idea, try to do something to replace all. Right, and they have a good reason, like Snowflake is there, S3 is there, right, and there's also balance. Sometimes people don't really want somebody main part as a starting point, but if they take the project to the next level, naturally they want using those bigger system for long-term storage, then it's really become a strategy like how much data is in, for example, time pass or is cached in time pass. But we have to support stuff like Snowflake, S3, or file systems.
Yeah, I mean, you don't want to do rip and replace as your main strategy because people don't like.
Yeah, if you try to do everything good, then you're always doing nothing good. So.
Yeah, that's it's really hard to be good at this.
Yes, I guess I'm not sure how long we're recording, but I guess pretty much is the meat of this episode of the streaming company.
The coffee is called.
All right, cool. And thanks so much for recording and enjoy the stay in Vancouver. And we'll see you soon in other conferences.
Thank you. I think I will see you in Connect.
That's awesome. Yeah. See you guys.